Almost live from Silicon Valley, California, brought to you by Mimosa Network. It's the Dustin and Eric podcast show.
Hello, I'm Dustin.
I'm Eric.
And welcome to episode number 4 of our podcast, Internal Networking, Connecting the Dots. Today we'll talk about network equipment and architecture. We also have a special guest today on the show, calling in Tyler Booth. He's a WISP operator. Hi, Tyler.
Hello.
Tyler, you want to tell us a little bit about what you do and how long you've been doing it?
Absolutely. We run a WISP in the Portland, Oregon market, and we've been doing it for 16 years.
That's quite a long time. How many customers do you have right now?
About 1,200.
Wow.
It's not bad at all.
Wow, 1,200.
A lot of work. Okay, so moving on here to catching up with D&E. Eric, so what'd you do this weekend?
Oh, I went. My wife and I went to the movies. We drove over to San Francisco to see. Is it Justin Bateman? What's that Game Night? The movie that's out. Game Night. Justin something.
Jason
Bateman.
Yeah,
that guy. So we took the 5th floor elevator up to the theater, and we got in there. We bought popcorn and hot dogs and stuff. And then we said, "Hey, man, which theater is Game Night in?" And they said, "Game Night? You mean Ready Player One?" I'm like, "No, Game Night." And I showed him my Fandango thing, and he said, "Oh, that's in the theater down the road, down the street." So we grabbed our popcorn, my 2 boxes of Raisinets, hot dogs. We took the elevator back down to the floor, downtown San Francisco on Market, walked down the block, and then went to the other theater and got there just in time. So that's what we did. Make sure you look at your Fandango app correctly and get the right theater, especially if you have 2 theaters within a block of each other.
Yeah, well, what's the point of having 2 theaters within a block of each other? It doesn't make any sense.
A lot of movies.
I guess so. Well, I've started hiking. I've been going over to the Black Hills in Los Altos and climbing up the hills looking for mountain lions. It's a mountain lion habitat over there, so always have to watch your back. They might jump out and eat you.
What hills?
The Black Hills?
Kentucky?
Los Altos Black Hills?
Oh, I thought you took another red eye to the East Coast.
No, not this time. No, I'm not going to go over to the Appalachians just to walk up the hill and then fly back.
That's where we go.
Oh, okay. And so that's about it. Just a little nature walk. I start doing that every weekend. So
that's good.
All right. And we're going on to the interrogation room.
The what room?
The interrogation room.
Oh, that one. And now it's time for the interrogation room, where we answer submitted questions from the audience.
Okay, so here's question number 1. So I've purchased some Mimosa A5C radios for my network. What antennas should I buy? Well, it really depends on what you're trying to accomplish. There's several different choices out there. There's the KP Performance 4x4 sector. There's the MTI 65 degree and 90 degree 4-port sector. And then there's RF element horns out there that you can use. But again, it depends on what you're trying to do, what kind of deployment you have. It's best to actually go look at these in the design tool. I know we don't have RF element horns in the design tool currently. Hopefully soon you'll see that.
Yeah, we're looking at the patterns, ASL, and so on, because of the field out there.
Right.
The spread between the guy to the left in the spectrum and the right.
Also, you can contact Mimosa sales rep or Mimosa support, and they can help you with your designs as well, as long as you've got those already in the design tool. Okay, question.
You forgot to mention the N5360.
Well, tell us about it. Do you have any yet? Oh, wait, I don't guess you have any yet, do you?
I don't.
So the N5360 is basically an omni antenna. It's a 4-port antenna designed exactly for the A5C. It's got 2 180-degree antennas inside that overlap one another, so you get 2 chains on your C5 or your C5C. It's available now. You can order that from your most popular reseller or distributor, wherever you'd like to go. But it definitely doubles the distance of a normal micropop deployment that an A514 usually sees, which I know Tyler is eagerly awaiting at least one, if not 10.
It's somewhere between the first and the second option, yes.
Right.
So question number 2, can I use other vendors' client radios with Mimosa access points? If you run the A5 or the A5C in Wi-Fi interop mode, you can use other vendors' client radios as long as you have them configured correctly. Do you run any like that, Tyler?
We do have some. We've got some of the legacy Ubiquiti M series, which are 802.11n compatible. So as kind of a strategy to migrate from Ubiquiti to the A5, A5C and A514, we've put the A5s in Wi-Fi interop mode, and all of our clients then connect back up to the Mimosa AP, and that allows us to one at a time pick off each client, upgrade them to a C5C, and then once we're all done, we can upgrade them to the SRS TDMA mode.
Exactly. Perfect.
Now with the M5, we're still looking at in SRS mode. We're still looking at 44.
Right. Currently,
clients.
44 clients total
Yeah.
on SRS, whereas with Wi-Fi interop, you can go up to about 100. And question number 3, how do I determine which Mimosa client radio to use? Well, it depends on your noise floor and the distance you're trying to achieve with your connected clients. So for short-range clients, the C5 will work well under 2 miles. Again, it depends on your noise. And then for clients farther out than that, you can use the Mimosa C5C with a larger connectorized dish or flat panel antenna, whichever you want to use. It just depends on the aesthetics for the customer and how far out you are.
We've got a couple of 2 mile, maybe 2 1/4 with the C5C, using it like a small 24 dB dish, for example, somewhere in that neighborhood, and then up to maybe a 30 dB dish at about 5 miles, for example, running. Yeah?
Right.
On
Yeah,
the
we've got
C5Cs,
the flat panel MTI 24 dBi,
and the AP, yeah.
and then we've got the Jiris 24 dBi parabolic dishes that are we're using that seem pretty decent. We've got a couple of RF element dishes here that we're going to try out soon also. So looking forward to give those a try as well and see what kind of performance we get out of them. And number 4, I came up with a potential network design for my town. Can you take a look at it and give me recommendations? While I'd love to be able to do that for you, unfortunately, I have way too much going on. But again, like we talked about earlier, if you talk to your sales rep or you come to support, they can kind of look at what you have in your design tool and let you know if it looks feasible or not. But keep in mind that even with your designs, it goes back to one of our previous shows where you need to actually go out and site survey the areas and look for trees or buildings, because the design tool does not take into account anything other than topology. And question 5, does a home router interfere with client radios? Eric, do you want to handle this one?
Home router. Yeah, actually, we've if we run into, we put a router. We look at maybe existing routers in the house and move those channels away. Even an auto channel on 5 gig, for example, we'll try to move that to one of the last channels. We'll also look at the spectrum as well, see if there's little blips in there, et cetera, and try to move away. And maybe you want to elaborate on that a little more.
So they do interfere with client radios. We've seen where auto channel routers actually follow the channel of the Mimosa client radio. So we have to set those to, basically the last channel available on the 5 gig spectrum to keep those away from the channels we're using to keep interference from happening, at least from that customer particularly. Do you have any trouble with that, Tyler? Do you guys provide Wi-Fi routers?
No, we leave our customers, we let our customers choose which router they want to use, but we do work with them on the installation to help get it set up properly, make sure that they're not using overlapping channels. But, to be honest, in 5 gig, the antenna is sitting at the edge of the house, and the client router is down below outside of the beam width of that directional antenna, and most often we're using a very high directional 30 dB dish So the noise level that the AP will see the client at, or sorry, the client will see the router at is generally pretty low. And yes, the auto gain control takes care of most of that.
Awesome.
Yeah, we'll look at positions of positions on the outside of the house for the dishes as well, in relation to where, you know, the Wi-Fi dual band or single band, whatever they've got, you know, wherever that's located at, and try to connect the dots there to minimize any interference in the spectrum like that.
All right. So coming on here to the main course, which is internal networking, and we'll jump right in here with network equipment. So first we'll talk about routers. Routers are very important to a network. You can't route traffic anywhere without a router in place. There are many different routers out there, and they're not created equally. Cisco and Juniper routers are pretty great, but they're also extremely expensive. MikroTik is a very inexpensive solution, but also a very popular solution among WISPs, and do a lot of the essential things needed for a network to run. And I think that you have MikroTik in your network, right, Tyler?
Yeah, we do quite a bit.
And I know that
it's a very cost-effective and flexible solution.
Right, and I know that we actually use MikroTiks here as well. And then the next thing is actual managed switches. So managed switches are excellent for enterprise networks. You can manage each port, traffic management, port management. You can set up VLANs or any other type of fancy routing that you need to do, or switching that you need to do. You can do MikroTik again, Cisco, Juniper. There's a lot of choices out there. But again, it comes down to price and what you need it to do for you. So a lot of people are happy with MikroTik, but a lot of bigger people out there use Cisco or Juniper because of the reliability, or because it has additional features that they think they need, or they know they need. Then you also have unmanaged switches, which are good for a variety of things, especially when you don't need a lot of management. An example would be when you have one port on your router specified for a particular network. Then you could hook up a switch so you can hook up multiple devices or radios to that specific network. So it's basically just increasing what you can plug into a single port on a router pretty much. And so there's a lot of options out there as well. There's Netgear, Linksys, all the common names out there. They're pretty inexpensive, but again, some of them aren't as reliable as others. It really depends on how much, they cost, how they're built. And so you just have to kind of research and find out which unmanaged switch might be right for you. I know that most of ours are Netgear, and we haven't had any real trouble out of those, but other people might say something completely different. And then
from a service provider standpoint, we tend to stay away from the unmanaged switches just because we don't have any visibility into our clients. Just something as simple as port status being up or down. You don't get that kind of visibility with an unmanaged switch.
Right. So it just really depends on how you want to build your network. So listen to Tyler. He knows what he's doing. And then we come to firewalls. Firewalls are used to help protect your network and your clients from malicious attacks from outside your own network. They can also be used to help protect from malicious traffic from leaving your own network as well. Some examples would be coming into your network would be targeted denial of service attacks against a client or multiple clients on your core network. There also isn't much out there that can help protect you from a DDoS or distributed denial of service attack, though. Examples of malicious traffic leaving your network would be like an infected computer or a client's residence, infected devices on their network. They can try to reach out to the internet. A lot of hackers will infect people's computers and use them as zombies to help with their denial of service attacks on other people. So these can cause issues for your network, adjacent networks, or networks in the cloud, basically. Do you get any kind of DDoS attacks, Tyler, or any just denial of service attacks that you see?
We've had denial of service attacks a few times. The MikroTik, actually, this is something we use the MikroTik for, is it can gauge the volume of traffic going to a client. We can say, well, if we expect no more than 20,000 on average inbound new connections, and that threshold is reached, we can then send a BGP message back up to our service provider saying, this IP is being compromised, please black hole route it. And then at that point, that particular IP address is just dropped at our service provider and it doesn't hit our network.
All right, excellent. And then we come to servers. Servers can be used for a multitude of things at your sites. They can be used for iPerf testing, backdoor remote access, for monitoring, or even as DHCP servers for your network. You can use desktop computers, laptops, actual server boxes, or things like Orange Pis or Raspberry Pis. Orange Pis are similar to Raspberry Pis, except they usually come with 1 gig Ethernet ports, so they're better for your iPerf testing if you're wanting to try and test speed between point A and point B, whereas with the Raspberry Pi, you're limited to 100 megs. So it's not as good for some things. It's okay for others. It just depends on what you want or what you're trying to do. And then we're going to move on here to actual network architecture. There are many ways that you can route traffic on your network because it depends on how your network is built or how you're building your network. I will talk about some different types of routing, but it's up to you on how you route your traffic. There isn't a one network fits all setup. You have internal routing protocols and external routing protocols. Internal routing protocols, or IGPs, exchange routing information within a single routing domain. External routing protocols, or EGPs, exchange routing information between autonomous systems. So some common internal routing protocols are OSPF, which is Open Shortest Path First, RIP, which is Routing Information Protocol, ISIS, which is Intermediate System to Intermediate System, and EIGRP, which is Enhanced Interior Gateway Routing Protocol. But most of these aren't really used anymore. The most common one is OSPF, which is used quite a bit. Basically, if you have redundancy set up, you've got multiple towers connected to your network, and you lose one of those towers or a path goes down, then it'll reroute your traffic through a different link to help bring back your clients or your customers that are down on the other side. And some common external routing protocols are BGP, which is Border Gateway Protocol, and EGP, which is Exterior Gateway Protocol. And so I think that, Tyler, you want to tell us a little bit about what you have set up on your network?
Sure. So we use BGP exclusively for both internal and external routing. BGP is basically the only standard on the internet. Anytime you connect to an upstream peer or transit provider, you're going to be using BGP if they're doing any kind of dynamic routing. A lot of WISPs getting started will get an IP block from their transit provider and start doing static routing from site to site, and until they realize that it doesn't scale, at which point they try to figure out some sort of dynamic routing protocol to augment their internal network and allow you to set up new towers and new sites without having to add the new network block to every single router in your network each time you add a new site. So we use BGP for that just because it's a layer 3 routing protocol. It seems to be a little bit more stable across wireless links than we found with OSPF, at least under the Microtik platform, which is what we use for most of our tower-to-tower routing.
I think that routing is the most daunting part of running a network. It can become very complicated, especially when you aren't sure what you're doing. So luckily, you do know what you're doing, and you do most of the routing yourself, right? Or do you have somebody on staff that does that for you?
We've got a couple of people on staff that can handle most of those types of things. But yeah, getting a foothold on BGP without any prior experience, and it can be daunting, and it took a while for us to make that leap.
Right. Well, luckily there are a ton of resources online in the WISP industry. So Link Technologies is actually one of those. They provide training and assistance to their customers using Microtik routers. So I know that Link Technologies actually sat down with us for a few sessions and helped us with BGP routing here on our own network. So there's lots of places out there to get help or to learn more, for sure. And so next we're going to talk about layer 2 versus layer 3. So basically, should you bridge your entire network or should you route it? Well, I've seen and I've experienced networks that are bridged only. So this means that there's only one router that you have, which is where your main backbone is located. Everything else runs on bridged radios and switches each tower or micropop location. While it's extremely easy to deploy, it's also very limiting to your network and to your customers. Here's just one example. Say you have a customer named Mr. Campbell, and he loves to click on every single pop-up. Well, as we all know, or should know, is that it's a very easy way to pick up some viruses or some malware. Well, on a bridged network, if Mr. Campbell gets some nasty stuff on his computer or another device, it could quite possibly affect all of your network and your customers. With a routed network, you have routers at each hop or tower, location, or micropop, and this helps so you can create complex routing to keep your customers online even if you lose a tower site or equipment on a tower site. If you're running a layer 2 bridge network, having any type of redundancy is impossible. With a layer 3 routed network, your tower sites could use OSPF to reroute traffic to another tower to get back to your main POP. And so I assume that you guys have plenty of redundancy in your network to keep everybody online as best as possible.
Yeah, that's something we also use BGP for is creating network rings, and this layer 2 design is another pitfall that a lot of new WISPs getting started will go down is just creating giant bridges, and as your network grows, it's really not sustainable. Having a very large MAC table that has to be broadcast across the entire network, and all the management broadcast traffic that flows over that. So yeah, every site we have is routed with typically at least 2 paths in and out using BGP for failover.
Right. Yeah, I have, like I said, I've experienced a bridge network firsthand and no redundancy, and it was quite a hairy situation a lot of the times, losing a tower or something like that and having to try to get that back up and all your customers behind that one tower. So definitely want to go a direction with routers instead of just unmanaged switches. All right, so next up we're going to talk about public IPs versus private IPs. So you have public IPs and you have private IPs. The public IPs are just like the name implies. They are advertised to everyone and everything out on the internet. They're usually used only for WAN addresses to communicate with the rest of the internet traffic out there. When public addresses are assigned, routes are programmed into the routers of the internet so that traffic to the assigned public addresses can reach their locations. Private IPs are the exact opposite. The IPs are only routable on your internal network for you and or your customers. Some ISPs out there use public IPs for both their customers and for their WAN routers. While this helps you access the equipment or networks from outside your own network, it helps others do the exact same thing. You want to try and protect your network and your customers the best way you can. So some private IP examples are 10 dot addresses like 10.x.x.x, 172.16 addresses, 172.16.x.x, and then 192.168 addresses, which are pretty common on home routers. Those are private addresses, and so you can use those the same way in your internal network as well. The result of many organizations actually using private IP addresses is that the private IP address space is reused, helping to prevent the depletion of public addresses, which with IPv4, they're actually almost out. All those have been pretty much allocated to providers. They've bought blocks of them, which is why a lot of people are moving over to IPv6, which there's more of those addresses, but it's still a finite amount on either one of them.
Finite number of addresses in the IPv4.
For both IPv4 and IPv6, but there's many more IPv6 addresses out there. And so the last thing here we'll talk about today is VLANs versus subnetting. So local area networks, or VLANs, allow us to create different logical and physical networks, whereas subnetting simply allows us to create logical networks through the same physical network. You can have one physical network and configure two or more logical networks by simply assigning different IP networks like 192.168.0.0 and 192.168.1.0, etc. The problem here is that even though you've created different networks, they are all using the same backbone, your switch. Traffic going through the switch can be seen by all other hosts no matter what logical network they are on. The result is that security is negligible, sensitive data can be easily captured, and there would be a decreased bandwidth availability since everyone would be using the same backbone. If your switch can handle VLANs, you can create one VLAN for each logical network. This effectively means that each network's data is separated on different highways. The bandwidth availability for each VLAN is now maximized, and we also have a decent level of security since the switch that connects each VLAN network will not allow traffic to flow between them unless configured to do so. So Tyler, do you do VLAN, subnetting, or a little bit of both?
Just VLANs. We don't do any shared subnetting. Well, I guess that's not entirely true. We do have additional subnets. For instance, if we ran out of IP space at a tower and we needed to add another client-facing subnet, they would live within the same VLAN, but there's no reason to segregate that traffic from a security standpoint.
Right.
But management traffic, for instance, is all living on a private IP address, and it's protected within a management VLAN.
All right. So let's do tech tips here. So this week's tech tip is brought to you by your local theater.
In a world of high fashion stands a man, Ben Stiller, Zoolander 3. This time, it's on.
All right. So this week's tech tip is has to deal with graphical glitches and incognito mode.
Oh, so your UI, so user interface. So if I'm trying to load a page, and then I get it doesn't refresh, I can't see the whole page. I can go to incognito mode, or I can try that. If I'm in, I try Safari, and I can't get the page to load on the UI, and I go to Chrome, and I'm having an issue there. I might go into, clear my cache, or go to incognito mode, right?
Right.
And at that point, they don't use cookies and etc. Is that something like that?
Yeah. So with Chrome or Firefox, Safari, Internet Explorer, they all have their in private mode or incognito mode, which doesn't use caching or cookies. So if you're having problems with the UI loading up or it not loading at all, but you can ping the device, try going to your in private mode and typing in the IP address, and it should come right up if it's just a graphical error or a caching problem.
Just kind of a clean. You go to that part of the browser and just kind of a clean load.
Right. Okay. So basically, this week we talked about network equipment, routers, switches, firewalls, servers, and actual network architecture, where we talked about routing, different protocols there, internal and external, layer 2 versus layer 3, IP structures with private and public addresses, and VLANs versus subnets. We also had Tyler join us today from Step House in Portland. Thank you very much for coming to the show.
Thank you. It was a pleasure.
And so next week will be podcast number 5. We'll be talking about building your infrastructure. So we'll go over installation and configuration of testing of equipment. Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.